Installation of centrifugal pumps. General reference and guide. Welcome to the general video reference and guide. Please read the product manual before installing the machine to get an in-depth knowledge of how the pump works and how to install it. This is a brief overview and a demonstration of the entire process covering the key points. For further information, you can email your queries to us on service@synpecpumps.com. Planning the installation. Before installing the pump, ensure that the foundation on which the pump will be placed is prepared well. It has to be sufficiently substantial enough to take the weight of the pump and absorb any possible vibrations from it. The foundation has to be absolutely straight without any inclination or tilting on any side. The foundation bolt of proper size should be embedded in the concrete and base plate tightened, ensuring that it is level in all directions. Piping associated with the pump must be anchored and supported independently of the pump and should never put any strain on the pump casing. When the pipes are not supported, their weight is borne by the pump casing and may cause them to crack or deflect. It is important that the connections be carefully aligned axially, angularly, and in length. Suction piping in case of suction lift condition, negative suction. The piping run and the connection fittings should be properly aligned and supported separately. The elbow should be of long radius type. All suction piping must be airtight. The suction pipe should be sized to ensure the liquid velocity of not more than 2 meters per second. The suction pipe size should be at least one commercial size larger than the opening of the pump inlet. All suction pipes should have a continuous rise to the pump suction inlet. 6 mm per 100 mm slope is recommended. No isolation valve is recommended. There should be a tapping provided for installing a vacuum gauge in suction line. The reducer joining the straight length of the pipe in the pump line should be an eccentric reducer with the inclined side of the reducer as the bottom side. The straight length of the pipe after the eccentric reducer should be 2 times of the pipe diameter. The suction strainer must be at least 4 times the suction pipe area, and the mesh size should screen out solid particles that could clog the impeller. The minimum depth of submergence of the strainer should be at least 3 times the pipe diameter measured from upper row of holes of strainer. The distance between the bottom of strainer and the floor of the tank should be considered as 2 times the pipe diameter. Suction piping in case of flooded suction condition, positive suction. In case the water is being supplied to the suction through gravity, for example an overhead tank, a slightly different setup is needed. The elbow should be of standard type or of the long radius type. Isolation valve should be provided in suction line. The pipe supplying from the tank into the pump should have a descending inclination. The straight run of the piping leading to the pump suction nozzle should be at least 3 times to 6 times the diameter of the pipe from the upstream elbow. The suction pipe should be sized to ensure a liquid velocity of not more than 3 meters per second. There should be a tapping provided for installing a pressure gauge in the suction line. The reducer joining the straight length of the pipe in the pump line should be an eccentric reducer with the inclined side of the reducer as the top side. Description of the discharge pipe. There should be a pressure tapping as close to the pump outlet and before the isolation valve as possible to measure the pump shut-off head. Concentric reducers are installed in the discharge pipe to minimize friction losses. The check valve used in the discharge should be of non-slam type to prevent hydraulic shocks. The isolation valve is provided downstream of the check valve so that these can be taken up for serving whenever required. Discharge pipe size should be at least one commercial size larger than the opening of the pump outlet. The number of fittings and size changes should be minimum to prevent fluid friction losses. Expansion joints may be used only after a careful piping analysis, especially when the discharge pressures are on the higher side. Installation of pump and prime mover. The pump and motor unit needs to be fitted firmly onto the base frame using nuts and bolts before fitting in any pipes. It is essential to confirm the distance between the shaft ends. In the subsequent step, the pump and the motor are aligned to the final tolerance using a reverse dial gauge or a laser alignment tool. After the alignment is completed, the piping associated with the pump should be bolted. Once this is completed, the alignment should be rechecked and similar readings should be obtained. If this is not the case, then the piping should be investigated and suitable corrections should be made. If this is left unattended, it can cause stress on the pump casing. The motor should be wired correctly to ensure the correct direction of rotation. This check has to be carried out before the pump is coupled. Once the pump and motor have been coupled, test the movement manually by rotating it by hand to see if it is rotating smoothly. Pre-operational checks. All cooling water lines connected to the pump need to be flushed. The cooling water lines are opened and circulation of liquid is ensured. Bearing housing should be drained of their oil and refilled with fresh oil of correct viscosity. It is necessary to confirm that the supply and return cooling lines are connected to their correct header. Place the coupling guard and tighten the bolts. Ensure that pump suction valve is fully opened and all joints are checked for any leakage. The opening of discharge valve is kept closed as this prevents the overloading the prime mover.